This is the Day 2 presentation of Section 8.6, Identifying Special Quadrilaterals. So as I talked about in the previous video, being able to identify and classify items or information is super important. So I talked about how doctors use their expertise and information from their patients to be able to determine the best course of action to remedy, I guess, whatever is ailing them. So we're going to just, again, take a look at a little bit of a few quadrilaterals in here and try to identify what type of quadrilateral they are. So here we go. Here's a quadrilateral. So I have quadrilateral A, B, C, D. And the only information that's given to us is that the distance between A and M is equal to the distance between M and C. The distance between B and M is equal to the distance between M and D. So the diagonals here, you'll notice they're bisecting each other. So diagonal BD is bisecting diagonal AC. And the diagonals are not congruent to each other. So the diagonals are not congruent, and you'll notice also too, even though they might look like they're 90 degrees, that information is not given. That this is, so you can't assume this is 90 degrees because it's not listed as a right angle, or there's no other angle measures that you've got here to figure this out. So basically what we have here are diagonals cutting each other in half, and diagonals bisecting each other is one of the characteristics of proving that we have a parallelogram. So in this case, the only information that we have here that we can go on are the diagonals bisecting each other. In this case, this is just a parallelogram. It might look like something else, but with just the given information, that's all we can go with this particular figure. All right, taking a look at this one, you'll notice again, I've got quadrilateral ABCD. In this case, the diagonal distances between B and M, C and M, D and M, and A and M are all exactly the same. Now again, I don't have a right angle here, but I do know that the diagonal distances are equal to each other. And when diagonals are congruent to each other on a quadrilateral like this, and they're bisecting each other, so M is a midpoint between both diagonals. Diagonals are bisecting, diagonals are congruent. That makes this a rectangle. All right, moving on to the third and last one. So what kind of quadrilateral is this? Well, we look at this and like, wow, man, this is screaming trapezoid. It's got to be a trapezoid. It has to be a trapezoid. But we've got math work to do first before we can make that determination and call it a trapezoid. So we know there's 360 degrees inside of a quadrilateral. That's the n minus 2 times 180. So n is 4 sides, minus 2 is 2. 2 times 180 is 360. And I'm going to subtract my known angles of 74 degrees that I have twice, and the 105 degrees. So when I subtract all of these down, okay, and take 360 minus 74 minus 74 and minus 105, I'm going to get 107 degrees. So this is 107 degrees here. All right, so because this is 107 degrees, I don't have opposite angles congruent. I don't have consecutive angles supplementary. All right, all I've got here is just a garden variety quadrilateral. It's just a quad. There's nothing else going on here that makes it special. So that's the type of work I'm going to be expecting you to do throughout the remainder of this section. So your assignment for Wednesday, I want you to do questions 12 through 16 and 18 through 20 on page 546 to 549. And thank you for watching this presentation. This takes us through Chapter 8.